Buongiorno, it's the video 13-1, solutions, colloids, suspensions, and electrolytes. So, we're looking at chapter 13 now. Everything here is dealing with solutions. Okay, so, what is a solution? You've seen this definition before. It is a homogeneous mixture. Okay, and it has to be a mixture. Two or more substances, and they have to be in a single phase, even though the substances could be in two different phases when they start. Okay, so it's homogeneous, so same compositions and properties throughout, and one substance has to be soluble in the other. Soluble meaning it dissolves. Okay, and the substances are small enough, the soluble substances, so that you cannot filter out the substances. So you cannot separate the mixture by using a filter. Okay, two parts to the solution. The solute, and the reason why you can't filter it out is because the particles are really small, 0.01 to 1 nanometer in diameter. Okay, the stuff that gets dissolved, this is called the solute. The thing that does the dissolving is the solvent. Okay, and sometimes this is called the dissolving medium. Okay, now, types of solutions that you can have. Any phase can be made to dissolve into any other phase. Okay, and you can say, how can a solid dissolve into a gas? Well, if the particles are really, really small, then it is possible for them to dissolve into the gas. Okay, so all combinations, solid to a gas, solid to a solid, etc. Okay, now for like phases, how do you know which one is a solute and which one is a solvent? Okay, simple. Whichever one is present in the larger quantity, that will be the solvent. Okay, alloys. How do you make a solid into a homogeneous solution? Simple. Okay, well, when you do, these things are called alloys. And the way you do it is obviously you can't mix the solid with the solid. So you have to melt them first. Okay, two types of alloys you can have, substitutional and interstitial. Okay, remember these two types. It'll show up in the lab that you guys do this chapter. Okay, substitutional, what happens? The atoms are of similar size. Okay, so what happens? One atom replaces the other one in the matrix of the solvent. Okay, now, if the atoms are really small, okay, these are going to be your solute atoms. The solute is basically smaller, so they fit in between the little spaces. So these are called the interstices. Okay, between the larger solvents. So basically here, think of like pebbles replacing pebbles. Okay, and here, think of like sand going in between pebbles. Okay, examples of different types of solutions, you can find it in the book. Okay, now, next thing we look at, suspensions. Okay, here the particles are really big. Bigger than 1,000 nanometers. So in a lot of cases, you can actually see the particles in your suspension. Okay? And this has to be a heterogeneous mixture. Different parts will have different compositions. Okay? And because these things are really large, you can actually separate out the suspended particles by using a filter. Okay? Or if you just let them sit there, a lot of times the particles will just settle down to the bottom of your container. Okay. So if you want these things to be equally distributed, you have to stir or agitate, shake up the solution to keep the particles suspended in the mixture. Even when they are suspended, it's still not going to be homogeneous. It's still going to be a heterogeneous mixture. Okay. So suspension, something like this, muddy water. Okay. And if you let it sit there long enough, obviously you'll see all the sediment settle to the bottom. Okay, that doesn't mean that the top is still completely clear, though. You still have some suspended particles in the top. Okay, next type of mixture we have, colloids, okay, or colloidal dispersions. This is what happens when you have particles that are between 1 and 1,000 nanometers. Above 1,000 nanometers, it's a suspension. Below it, it's a solution. Okay. Now, these particles are still small enough that you can't filter them out. They pass through the openings in a filter. Okay. Two parts to a colloidal dispersion or colloid. The dispersing medium, this is similar to the solvent in a solution. Okay, and a lot of times it's going to be water. And the dispersed phase, this is similar to your solute. This is the stuff that gets dissolved. Okay, now um, the reason why these particles, even though they're kind of big, don't settle out to the bottom is they're kept suspended by collisions with particles in the dispersing medium. Okay, so a couple of different examples of different types of colloids also in the book. Okay, now there's something known as the Tyndall effect. Okay, the colloidal particles basically are large enough to scatter light. Okay, so how can you tell the difference between a solution and a colloid? Okay, well, in a solution, the particles, the solute particles, are too small so that if light hits it, light will just pass right through. In a colloid, the particles are large enough so that light will actually, when photons hit the particles, will get scattered. Okay, so as a result, if you were to shine light through a solution or through a substance that was a colloid, you'd actually be able to see the beam of light. Okay, solutions, you wouldn't be able to see it. When you look down to see is there light passing through, you wouldn't see any light. Okay, so an example, this one right here, this is a solution. Okay, and notice there's a laser pen right here shining a beam, but you can't see the beam in this section right here. When it exits this one and goes through this solution, which is a colloid, you do see the laser beam because the particles in here are big enough so that they'll actually scatter the light upward in all different directions, so you can actually see the beam. Okay, now if you were to actually look at a colloid under a microscope, the dispersing medium, the water, would be too small. You wouldn't be able to see the particles, but you'd be able to see the dispersed phase, the solute type things. Okay? And you may see that they look like they're just moving all around, all just by themselves. Okay? This is known as Brownian motion. Okay? And the particles aren't alive. What's happening is the dispersing medium is basically bumping these particles. Okay? So something like this would happen. You couldn't see why these particles are moving right here. Whoops. Okay? But the reason why they are moving is because the dispersing medium, or the water or whatever would be in here, is bumping into the particles and making them move. Okay, now electrolytes and non-electrolytes. Okay, ionic compounds will break up into ions if they can dissolve in water. Okay, not all ionic compounds will be able to dissolve in water. Okay, if they do break up into ions, then these substances, not the solution, but the substances, are known as electrolytes. Okay, substances that will dissolve in water to produce a solution that conducts electricity. That is basically what an electrolyte is. Okay, in order for the solution to conduct electricity, remember, you have to have free-flowing charged particles. Metals will conduct electricity because they have free-flowing charged particles. They're not ions, they're electrons. But in ionic compounds, these are going to be ions. Okay, so what can happen? You have something like sodium chloride here. Okay, so these are your sodium ions, and these are your chloride ions. Okay, and right now, they can't move very much because they're basically stuck in place, strong ionic bonds. Okay? Water can come in, latch onto these things, surround them, and move them away. And as they move them away, now these particles are free to move, so now this solution right here would conduct electricity. Okay? Certain other polar molecules will react with water when they dissolve into water. And even though these do not have a charge to them, because they react, they turn into ions. Okay? These are also going to be electrolytes. Okay? An example, hydrogen chloride molecule, when we dissolve it into water, it now becomes hydrochloric acid. Okay? What happens? The H2O actually reacts with the HCl. Okay? And, whoops, let's do it this way. The H plus comes off of the HCl, reacts with that, turns into hydronium ion, and as a result, you have an ion left over, which is the chloride. You get two ions, So acids will conduct electricity really well. Okay. Other molecules, just because a molecule dissolves doesn't mean it's going to produce an electrolyte. The solution will conduct electricity. Other molecules will dissolve, but nothing will happen to them. So they were neutral to start out with, and they don't have a charge. Okay, so now these solutions will not conduct electricity because you do not have any charged particles in them. Okay, and obviously these substances are called non-electrolytes. Okay, example would be sugar. So this molecule right here would be something like sugar. Okay, they're all stuck together. Same thing happens when they dissolve. Water molecules come and surround them and pull them away. So you see the sugar dissolve because the molecules break apart or they separate from other molecules, but these still have no charge to them. So it's free-moving particles, but they're not charged. So sugar will not conduct electricity, a solution of sugar water. Okay, so here's your review question. Okay, you look at a mixture and someone tells you, yep, this is a mixture. Okay, it's perfectly clear. So what type of mixture could it possibly be? Okay, pick your correct answer and also don't forget, be able to explain why.